First speaker to kick things off is Mark Ahlstrom, and now he's the Vice President of Renewable Energy Policy for NextEra Energy Resources and NextEra Analytics. And he's also actively involved in activities with NERC to support economic and reliable use of higher levels of clean energy. And he's also the president of the Energy Systems Integration Group, which was formerly known as UVIG, which is the Utility Variable Generation Integration Group. So I'll hand it off to you, Mark. Thanks.
Thank you, Brian. Now, thank you for inviting me here to your beautiful campus. I must admit that I'm a little bit intimidated by all the W's around here because I went to the University of Wisconsin-Madison, of course, and we won't get into Badgers versus Huskies or anything. No, but it's glad to be here. And, you know, I'm the sort of guy who works broadly throughout the industry to try to understand how things fit together. You know, that's how we communicate this is extremely important. How we put this into context is important. But it's a pleasure to be here. You know, Madison, Wisconsin had another great product that came out of there, which I refer to frequently. And by that, of course, I mean, how we do this. How do I advance? Oh, there it is. Okay. By that, of course, I mean The Onion, the satirical newsletter. Came out just, I guess I graduated already by then, but it's a great source of some really good writing about, you know, satirical look at what's going on in society. I especially like the stuff on the right there. They call that American Voices, where they come out with the man on the street interviews kind of thing about what's going on. You know, so that's with this sort of context, we get a lot of news out there. You see a lot of headlines. It's often hard to tell, you know, is this real or is this not real in so many ways? And actually, I see a lot of that in our trade press as well. For example, I've been seeing headlines like this the last few months, and I have to look twice. I say, you know, is this real? I mean, Idaho Power sets goal of 100% clean energy by 2045. With Cincinnati on board, 100 U.S. cities committed to 100% clean energy. I mean, nothing against, you know, Idaho and Cincinnati, you know, but this is a change, right? These are not always the most progressive places that we see coming out. It's more than just California and others. And also we have major utilities that are voluntarily making statements like this Xcel. Xcel commits to 100% carbon-free electricity by 2050. Particularly noting is what the CEO said in the press release just under that. The 80% by 2030 goal will be fairly easy and affordable to meet with currently available technologies. The incremental cost of renewable energy generation is now less than just running their existing coal plants. I mean, this is the big change. The cost of wind and solar, and now with batteries coming on as well, the cost of these resources is now the cheap cost of energy. It's very different than even just 5 years ago. You know, so this is a real game changer to see this sort of stuff. So society is getting on board with this. However, we know as engineers that, you know, the future is still pretty complicated here, right? The participants that participate in the grid are increasingly dynamic digital programmable devices, meaning mostly non-synchronous devices. Society is clearly demanding this cleaner energy, and they want us to do it in a way that is fair and, you know, technology agnostic, do it through markets when we can, make it scalable, make it reliable, of course. Also, when you point out that society here is talking about percentages of annual energy. So when they say 80% clean energy, they mean 80% of their annual retail loads, basically, right? We know that we have to also deal with instantaneous penetrations, and even maybe with stability issues about how much non-synchronous capability is connected, right? And responding in this way. I'll point out that there's one area, actually a couple areas in the country, ERCOT down in Texas and SPP, Southwest Power Pool is a good example of this. That's kind of in the southern Midwest, around the Oklahoma area, right? They're currently around 20% of their annual energy from wind. Last week, they hit 65.5% instantaneous wind. 14 gigawatts out of the 21 gigawatt load at that time was completely supported by wind. Probably could have been more if they thought they could handle it, right? So we are already at instantaneous penetrations that are getting very, very high, right? And we as engineers know that, you know, it's great to have 80%, 100% policy. We still have to make this work. So what are the current challenges I see? I mean, what I would call the old stuff is the wind and solar at this point. By old, I mean that we've been putting in, you know, gigawatts per year of wind for about 15 years now, right? Which, you know, in the power industry, that sounds like it's overnight, but in renewables industry, that is very fast. We're putting in, the last 7 years or so, we've been putting in solar plants at the bulk power system in the same scale. You know, and we have moved this forward. As many of you know in the room here, we initially did a lot of studies, with many integration studies, a lot of work at NERC and FERC and so forth. But we still, you know, we are putting these on increasingly weak grids sometimes. You know, we're running into very low short circuit currents and issues like that where it has to be tuned carefully. We want renewables, and I've been a huge campaigner of this, that, you know, you have to be a mainstream part of the grid. You're going to be the core of what we put in the future. Therefore, we already have successfully moved through NERC and into FERC, you know, interconnection requirements, that every new bulk system connected wind and solar plant has the capability of supporting primary frequency response. It provides dynamic reactive. I mean, we do not want technical roadblocks here as an industry either. You know, so we actually support making sure that these plants have the capabilities, and now starting to move those into market products and things like that as well. We've been doing that for, as I said, over 10 years, getting pretty good at it, but we do have to deal with these weaker grids and putting in more and more, and how we're getting to deal with the problems you're going to be talking about here for the next 2 days. The thing that's actually consumed me for the last 18 months or so has been what's happening with storage. FERC came out with an order called Order 841, which requires that storage, often battery storage, which is fairly new, has to have be fully able to participate in all the market products that it's technically qualified to provide, right? This is a game changer. I'll talk about this a bit more. We're doing, the big thing that's been a surprise to me has been combining storage very tightly with other, primarily PV, but eventually wind plants, often on the DC side of the inverters, right? Now, 5 years ago, I would argue, and in fact, I did argue. I went to GE when they were talking about putting storage in their wind turbines, and I said, that's a stupid idea. All you're doing is making, you know, the more expensive wind energy look even more expensive when you can get this flexibility somewhat cheaper from the system, right? Well, I've had to eat those words. I think we're going to see hybrid, you know, storage plus projects of all sorts. We're doing it now in large scale with solar. We're finding all sorts of reasons why we actually want to have storage there. And we'll talk more about that as well in terms of what we can do when we have storage and electronics, you know, behind this. Also, I expect to see an order from FERC about aggregated distributed energy resources in about a year or so. You know, these should be able to participate at the bulk system level as well. This, again, is going to be a game changer when you think about this truly virtual device now participating in that way. But what's really struck me is that storage has been such a game changer, because until you really get into it, you don't even think about how different it really is. I mean, is it a generator? Is it a load? It's both and neither at the same time, right? It's a very different disruptive beast. And as I said, I think we're going to see it tightly combined with all kinds of resources and participating both standalone and hybrid projects in ways that we can't even imagine at this point. Now, you know that this is a digital revolution going on here. You know that we're taking these conventional synchronous plants, we're replacing them with non-synchronous resources that are electronically coupled with fast power electronics. We also know that, you know, all these digital devices. I spent 25 years in the software industry coming out of college before I stumbled back into this space. Computers are really fast, but really stupid, right? We have to tell them exactly what to do. But what amazed me when I was, you know, in the early days of working with microprocessors in college, you know, you can put an emulator on a digital device, and you can turn it into whatever kind of device you want, right? We can emulate anything. That's the beauty of software. Look what we're doing with cloud computing now, where everything is running on virtual machines, right? I mean, so think about what this really means. In fact, I would claim, and if there's one thing that I want you to take away here, think about this, that given enough energy, electronics, and software, we can emulate any real or imagined machine we want or need, right? We know how to do this. We have to figure out what we want and what we need. But, with what's happening, especially with the advent of storage that's going to become cheaper and cheaper, and the power electronics and the controls we can do today, we are not limited by even what the current machines have been doing for the last 100 years. We can make them behave differently and better. The whole concept of, like we've been doing integration studies on wind and solar for, at least 16 years, right? And often they wanted to compare that with the ideal resource. The ideal resource in their mind was a really fast gas plant, right? Maybe you'd love to have a gas plant that could start instantly. That would be ideal, right? Well, we can do that, right? We could put power electronics and inverters with a gas plant right now and have an ideal plant like that. But we could probably do a lot better with the energy that we have behind this through storage and other resources. So don't be limited by what we're thinking here about what the ideal will be in the future. The other issue we have is we build these new resources. How do we use them? If you're actually like trying to run a grid and you want to take all these resources and put them into your energy management system software or your market management software to deal with them, traditionally, we started out where all we had was hydro and coal and nuclear. And so, they had certain capabilities. You had, here's my Pmax, here's my min, here's my ramp rate, here's how long it takes me to start up, right? It was a pretty simple set of parameters. But you were turning essentially your bare iron over to the system guys and said, what do you want to do with this, right? Here's what I can do. And when we came up with wind and then solar, at first we thought, boy, how do you deal with variable generation? I mean, this is so weird. But in terms of short-term integration into the 5-minute dispatch process of running the grid, for example, I think it was actually Eric Gila, when he was working at ISO New England, said, well, wait a minute, we can actually forecast what these are going to do really well for the next 5 or 10 minutes because the wind and sun doesn't change that fast usually. So all you have to do is kind of jam in the current telemetered value or the very short-term forecast as your Pmax. You run the software you already had, and voila, you're kind of dispatching the wind and solar, at least at the 5-minute level, right? But it wasn't a fundamental change in the parameters of how we wrote this software. What's happened with battery storage with 841 over the last couple of years now is, oh, wait a minute, there's all sorts of other parameters once you get into these fully digital, fully controllable devices, right? What's your state of charge? How do you want to do this? Can you switch instantly from charging to discharging, all this? So you're adding all these parameters. And this is a whole new, what they call a market participation model that FERC required. You got to write a new way that a battery system or a storage system can offer all this to the system and make the system software, the energy management and market software, figure this out. And I would argue that this is really just the first step of what we're doing with this digital transition, right? And I think in this industry, like we've seen with every other industry that has been digitalized, we're going to see a massive increase in the rate of innovation, rate of change. Because once we get to software-based devices, we can change them very fast, come up with new behaviors, right? And so every time we come up with a new innovation, are we going to have to go back and go to FERC and spend years and get a new way to allow us to even offer that to the system? I mean, who knows what we're going to come up with next? I mean, this is going to become onerous. So this is going to be disruptive for what we're doing on everything about how we operate the system as well. I see a couple of phases of this coming up. One is that about a year ago I said, from a software point of view, we've been dealing with complicated systems like this for 30 years, right? You don't write a different function for every little variant. You write a parameterized function, you use object-oriented programming, you abstract that. So I said, well, at a minimum, why don't you leave it up to the system, the market participant or the owner of the asset to better describe, here's what I can do today, and have a parameterized way of offering that more generally to the system software, right? It helps. It puts more of the responsibility on the person who has that resource to tell the system, here's what I'm capable of doing, and I might want to update my software tomorrow and offer you something even better. I can do that now. It's a start. It gets away from barriers to innovation, which is extremely important given the pace of innovation I think we're going to see in the future. It's still a very complicated system though, right? Because we moved a lot of this up to this very complicated set of parameters and how they interact. So if you're writing the EMS or work management software, you're still not too happy about this, because it's very complicated. So perhaps the next logical step is to step back and say, well, fine then. If we were going to start this today, and I am a controller, my butt's in the seat of the control room, my job is to keep the system balanced and reliable, right? Do I really want to care about what your startup time is or the quirks about all the hardware out there? Or if I were going to start from scratch, I would say, look, I'm the customer. I'm procuring these services from you. Here's the high-level services I want in order to balance and operate, maintain reliability of this system, right? In other words, let the customer ask for what they want. The customer in this case is the market or the control room system. They define these at a higher level, and they say, look, guys, you now have the capability of turning your machine into an ideal resource that can offer whatever these services you want to provide. You figure out how to do more of that. You do that by maybe doing hybrid systems or other higher level controls. You give me what I want because I'm the customer. I have enough complexity already. I don't need to worry about all your internal stuff. Move that complexity down eventually to the resources out there and say, how can you innovate? And it opens up all kinds of innovation. Behind your fence line at your plant or whatever, or your system, you can do whatever you want to come up with lower cost, better ways of providing the services that are most valuable to the system. Right? It's a big step. It's not going to happen quickly at all. It might be almost impossible to get through the stakeholder process of how some of the markets are operated today. But I think you are starting to see some of this already, sometimes outside of the markets, where they're seeing the value of this about building these hybrid resources and so forth. And I think what you're talking about here with grid forming inverters are a huge example of this. I mean, these are needed in the near future. This is not far off, guys. We're close to these 100% instantaneous penetrations, right? It's certainly important on microgrids and on the distribution system, but we need it in the bulk system just as much. I mean, we are hitting very, very high levels and tens of gigawatts of resources being put in every year now on these systems. So we need all the things you're going to be talking about here in terms of the modeling, the simulation, the capabilities of doing this. And I think really it's the grid forming inverters are going to be central to everything we're talking about here. You want that hybrid resource, you want that ideal resource to truly be ideal. And that means it's going to have to be grid forming too. It's going to have to run in without the conventional resources at least certain hours of the year. And this is happening faster than you can even believe. And we can create what we want here to do that. So these pathways and how we communicate these pathways more broadly to everybody else outside of this room are extremely important. I do believe that we can push with what we have today up to the 60, maybe 80% sort of levels that society is talking about for 2030. I think it's possible. We're already having to tune a lot of the stuff we put out there, but we could do it. But we're going to have to be grid supporting, if not grid forming, pretty darn soon. And oh, by the way, 2030 is not very far away, right? And so we have these choices. Are we going to, embrace, low inertia operations or put in more synchronous inertia? Are we going to, replace short circuit currents, or are we going to embrace other protection mechanisms? Are we going to change how we use or even think about, frequency, capacity, reserves, right? Everything is on the table here. And I must say that, what motivates me to continue to do this work and think this is so important is, how do we clean up the grid as fast as possible in a way that's economic and reliable, right? And I must say, I'm not really that much of a believer in 100% non-synchronous. I would be really happy if we got to 80% clean and we electrified all the other vectors that are using fossil fuels out there, right? We've got lots of other things we can electrify with transportation, heating, industrial processes, and so forth. So we may or may not get to 100% clean. We probably will not easily get to 100% non-synchronous at least for all hours of the year, but I think we will for some. So these are broad choices, and how we talk about this and how we explain it is extremely important. So we have to think about this, and the story really matters. And what we're seeing here is these very strong drivers. I mean, we talked about the press you're seeing out there, but right now at global rates, we're putting in 60 gigawatts of wind and 120 gigawatts of solar for the foreseeable future every year. We're going to continue to do this. NextEra Energy, the company that pays me to do this, so whether they know it or not, they're the largest developer, owner, and operator of wind and solar and storage in North America, but we're only about a little less than 20% of the market. We are building $4 to $5 billion worth of new wind, solar storage plants every year, right? So do the math, right? This is billions of dollars of plants going in. Most of what we do is at the bulk system level. We do some others as well, but this is huge. You're seeing these commitments, not just from some of these states like California and Hawaii and others, but you've now got multiple states that have this. You've got now about 120 cities that have said that they're going to be 100% clean. Often it's 80% clean by 2030, 100% by 2045 or 2050. You've got utilities, Xcel, Idaho Power, and others that are voluntarily doing this. You have corporate buyers that are voluntarily doing this. You have legislation pending in at least half a dozen other states to have a similar legislative requirement for 100% clean. In terms of NextEra, this surprised me a lot because our CEO has never talked publicly about prices and a lot of issues here. He's come out though publicly to our stakeholders and said, in the early 2020s, meaning like within 3 years, if not already today in some of the regions, that solar and wind plus storage will be cheaper than coal, oil, or nuclear, at least competitive with natural gas plants, unsubsidized, with all the subsidies gone, right? So this is not going to go away. I think it may change even more toward solar and solar plus storage in particular. In fact, what we're doing now is not just looking at solar plus storage as a gas peaker replacement. In Florida Power and Light, which is our utility half, they announced they are retiring a combined cycle plant, replacing it with a 400 megawatt lithium ion battery system, 907 megawatt hour, plus PV to charge it, right? I mean, this is large scale. This is big. This is going to be pretty much the only thing. I'd mentioned SPP, for example. They had 65% wind. In their interconnection queue, they have wind, solar, and storage that exceeds their total peak load by 2 to 3 times, right? The only thing we're going to be building, folks, is going to be non-synchronous plants and storage. I mean, it's not, a little bit of natural gas where you need it for some support for a while. But even Xcel, I mean, the reason Xcel did that was, even if the price is the same, it makes business sense for them to select like solar plus storage rather than natural gas, because you don't know what's going to happen with the price of carbon. There's a risk there. You don't know what's going to happen with the price of natural gas. So from a business point of view, if they can make it work, it's the right business choice. But please remember too, that communication on this is very important. Try to stick to standard nomenclature when we can. I see way too many cases where we come up with a brand new acronym that means the same thing as what we already have, right? It's variable, it's not intermittent when you talk about wind and solar. I consider intermittent to be, an insulting term, to be honest. I mean, when a nuclear plant drops off in a couple of cycles, that's intermittent. Wind and solar are constantly variable, I'll admit, but they are forecastable and we can do other things. So that's my own pet peeve. In terms of general nomenclature, NERC and now FERC have really centered on wind and solar are variable energy resources. On the distribution side, we have distributed energy resources, and we talk about non-synchronous versus synchronous plants. That you'll see consistently through most of the NERC and the FERC orders and so forth, so stick to that when you can. Try to be progressive and watch out for people taking your nice statements out of your paper out of context and using it in a headline someplace out of, for a completely different reason. I mean, we all like to get press for what we're doing and want people to know it's important, but, let's try to not say something like, without this new breakthrough, it's going to be prohibitively expensive and impossible to reach these goals. And oh, by the way, we don't really know how to do that just yet. So, the press that would be picked up in some places would be, it's impossible, this sort of policy statement is ridiculous. Just watch out, it's going to happen, happens all the time. But let's try to be very progressive that we can do this. We are well on our way of doing it. It's an engineering challenge, but we love challenges, right? That's what we're here for, is to help society do what they want to do and figure out how to make this work. The pathways are important. We have to get this we have to get this into production, guys. We need it. We need the vendors that are producing the inverters and the wind and the solar and the storage to be using this much sooner than you think. And not, as I said, not just at distribution levels, but up at transmission levels as well. There are lots of challenges, but we have to also communicate this outside of the academic sphere into the broader industry. And that, I know that means going to meetings like ESIG and IEEE, participating at NERC and places like that, which are, you don't get a peer-reviewed journal paper for your CV out of it, I know. But it's so important to go to these places and network with people throughout the industry. It's really what we try to do with our meetings at places like ESIG and IEEE, is to provide that safe place for people to talk about stuff like this. And it's very important. Just let's be careful with it. Let's be progressive. Let's know that we can solve this. These are exactly the sort of problems that we're really loving. And I'll tell you, the next 10 years is going to be an amazing time for this. So with that, you can certainly contact me at any time. You'll have my contact information. I'd be glad to give you a card as well. And I mentioned ESIG. If you're not familiar with it, that was mentioned by Brian. It's a nonprofit educational group. What we really do is convene meetings where we get people to talk about stuff like this. We'd have one panel on this and another panel on all kinds of other stuff, so you can meet everybody throughout the industry. And it's all the RTO ISO folks that are running the grid. It's the vendors, it's the utilities, and it's the researchers and academic side getting together in a safe place where we can talk about this in ways that we can't in a lot of the formal stakeholder processes and so forth. So we share our best practices, we share what we're thinking about. And I tell you, they've taught me everything that I know about what we're talking about here today and other things in the power side. So certainly everybody is welcome. All members are equal. So with that, I'd be happy to take questions now or later.
Mark. Yeah, I guess let's give Mark a hand. All right, I think we have time for maybe a quick question. So is there anything come to mind? Yeah, maybe one quick question I'll ask is, what are your thoughts on where the priority lies between bulk and utility scale versus commercial and residential scale?
Well, I think we're going to need it all, and we want to support it all. I will say, in terms of the megawatts that are being installed, and I think will continue to be installed, I think it's certainly going to be probably 2/3 on the bulk system and 1/3 on distribution levels. In my personal view, I think that will continue to at about that range. It's interesting because the cost, and if you're trying to really minimize the cost of serving society. There are definitely economies of scale, from doing the larger projects that we see throughout that. So you have to weigh, what society wants to do is fine. If other people want to invest in it, we want to support that, and there's certainly room for microgrids and everything else. But the bulk system needs this just as much. We're going to need grid forming inverters there, and my message is, let's not forget that we're going to need that much sooner. It's not a 20 or 25 year sort of path we're on, folks. It's a 5 to 10 year path for the bulk system as well.
All right, on that note, let's thank Mark one more time.